Kalam Hussain here, and I'm going to present my fifth practicum of Constitution, Computer Organization and Architecture. And let us dive into the questions which have been given in this practicum 5. Let's start with the first one, which is execute the MATLAB program for non-pipeline and pipeline execution using the same number of instructions and clock cycle time. Compare the total clock cycles, execution time, and determine which method is more suitable for real-time system. Onto the code. The first one we are applying values such as n, which is number of instructions, k is equal to number of pipeline stages, t clock is equal to clock cycle time, and the non-pipeline calculation, which is cycles non is equal to n times k, and time non is equal to cycles times t clock. Pipeline calculation is about cycles pipe is equal to n plus k minus 1, where n is number of instructions, k is pipeline stages. Time pipe is equal to cycle pipe times t clock, and we are setting speed up is equal to time non divided by time piper. From we are taking the two values from here and here, uh, time now divided by time pipe, and onto the displaying results. We are displaying non-pipeline excuse me, a non-pipeline execution. After that, we are printing out total clock cycles, and after that, we are printing out the execution time. And for the pipeline execution, we are printing out total clock cycles, and after that, we are printing similarly the execution time. And after that, we are printing out the speed up. So let us dive into the output. The number of instructions has been 5. The pipeline stages has been inserted as 4, and clock cycle time is 0.5. So here, what we have received is total clock cycles is for for pipeline is similar this n plus k minus 1. Non-pipeline is 20, which is uh, n into k, and after that execution time is uh, 20 divided by 20 times uh, the value which I have entered is 20 by 2, which is 10 seconds. And onto the pipeline execution, the similar formula applied, and we have derived the output here. And on to the second question, which is run the MATLAB program by increasing the number of instructions while keeping the number of pipeline stages constant. Analyze how execution time changes in both pipeline and non-pipeline modes, and comment on the variation in speed up. Let us dive into the code, which is we are putting the values k is equal to 4, and time clock is 0.5, and instructions have been given as 5, 10, 20, 40, and we are displaying the instructions non-pipeline time, pipeline time, and speed up. And we are using the for loop where I is equal to 1, length instructions, n is equal to instructions of I, non-cycle cycles non is equal to n into k, whereas in non-pipeline it is n times k, and in pipeline it is n plus k minus 1. For a time non-pipeline, it is cycle non times time clock, and time pipelining, it's equal to cycle pipelining times time clock. And in the speed up, we are dividing time uh, non-pipeline, and divided with time pipeline, and we are printing out the values and so on. So, and we have determined the values instruction as 5, 10, 20, 40, which is already given, and non Pipe time is 10, 20, 40, and 80, and we are determining it through n into k, which is n. The values of n which have been 5. No, no, it has been determined as n into k. So and so, and pipeline is so, and we have determined the speed up using the previous formulas and given which are given here. Uh, n is equal to instructions of 5. And on to the third one, which is execute the program by increasing the number of pipeline stages while keeping the number of instructions constant. Analyze the effect of pipeline depth on execution and overall performance. Let us dive into the code. On the first step, we are applying the value of n is equal to 10, which is constant instructions, and time clock is equal to zero point 0.5, and the stages are defined as 2, 3, 4, 5, 6, and we are displaying stages, non pipe time, and speed above. And we are using for loop, which is I is equal to 1 length bracket stages, k is equal to stages I, cycles non is equal to 9 nk, and for pipeline it is n plus k minus 1, and time non pipelining is cycles non pipeline times time clock, and time pipelining is cycles pipelining times time clock, and we are determining the speed up by time non cycle non pipelining divided by time pipelining, and we are printing out the values of k, time non time pipe, speed up, and we are determining the output. The stages have been given us such as follows: 2 to 6, and after that we are determining non pipe time, and speed up, which are these 10, 15, 20, 25, 30, which are like similar n into this, and so on. So pipeline has been determined and speed up has been determined. So that's it. These are the questions which have been solved, and I hope this will be useful. And thank you.